Okay, so this is lesson 11.3. Remember, we started everything with trying to understand what radicals were, and we looked at the aspect of the radical sign, the radicand, and the index. We also learned in that first lesson how to convert between radical form and exponent form and radical form. So we're just trying to understand a little bit of what radicals are. We also talked about how to take the root. And then in the second lesson, we talked about simplifying. And that's that key lesson. And most of you did well with that because your quiz, that back half of your quiz involves simplifying. And a lot of you did fine in simplifying on that back half of that quiz. So now what we have to remember is everything else we do the rest of the chapter, we have to be looking for simplification. If you do that, then you're in great shape. And that's really the aspects here of multiplication. Right, in order to multiply radicals, there's just one condition. The index has to match. So you can only multiply square root times square root, cube root times cube root, fifth root times fifth root. You cannot multiply a square root times a cube root, okay, etc., etc. Doesn't matter what the radicand is, but the index has to match to be able to multiply them. So if you finish off this rule here, you're going to have a radical. They both have an n index, so we'll keep that n index. And the radicand becomes the multiplication of the first radicand times the second radicand. They just become one radical. What becomes a key, though, is the aspect of the simplification. We'll talk about that in a moment. Okay, so let's go through a couple real simplistic examples. So A is really easy. It's a square root times a square root. We can multiply it, and you end up with, and I'm just going to do this maybe once or twice, not much, because we'll just do that step in our head, right? And so, of course, we end up with the square root of 21. Hey, that's easy. We're just multiplying. We know how to multiply already. And even if there are variables in there, that's a piece of cake. We can do that. No big deal. So again, normally in a problem like this, we'd go right from the original right to the solution, right? Square root of 55. We're just going to multiply the radicands. Square root times square root, so we're able to do that. We're in good shape. And therefore, there's no issue there. So obviously, if you had 3, go ahead and do that one. What would you do with that? Of course, you have no idea because we've never done one with 3, and, math is impossible, so I'm sure you won't be able to get it. But obviously, the answer to this is square root of, right, square root of 30. You're just multiplying the radicands. Piece of cake. Not a whole lot involved there. Very simplistic. Where you have to be careful is this next aspect. What happens is, just like in factoring, do you always have a common factor to factor out? No. And because of that, students forget to factor out common factors first. Do you always have simplification that takes place? And the answer is no. And therefore, students forget all about simplifying. And you can't do that. You always have to be looking to simplify. Always, always, always. And in reality, it's a whole lot easier if you simplify before you multiply. So we're used to reduce before we multiply, right? The concept of, if you had 2 fractions, so don't draw this, but just refresh your memory, right? If we had a 6 over 11 times a 5 over, let's not use 10, times a 5 over, let's say, 33, we know that it's going to be top times top, bottom times bottom, and we know technically you get to this point, and then you reduce, but we say, hey, just reduce right here. 3 and 11, 2 and 3, 3's are gone, and now finish it off, right? And we're going to reduce before we multiply. It's the exact same concept here. We're going to simplify before we multiply. So before these become 1 and the numbers get bigger, let's simplify first. Okay? So that's the aspect and that's the idea. So technically, this is what you don't want to do. All right, you're used to just multiplying. You don't want to say the square root of 18 and then simplify. For one, you just made it more complex by multiplying it out. How do you simplify? By unmultiplying. So now you just made a whole lot more work for yourself, and that's silly. So we're not going to do that. We're just going to right here, because we know they're going to end up being one radical, I'm just going to look right here at what factors I have. All right, so factor your 6. Because you know a 6 has a 2 and a 3. All set. All right, very good. Let me know if you'll need a note for next class, okay? And I'll write one for you later. Okay, so you look at that, and your next thought is, hey, this is a square root. A square root, I need 2 of any factor to be able to take the square root. And you say, hey, I've got a 3 here, and I've got a 3 here. So technically, if you were going technically, you might want to say, okay, I got a 2 times 3 times 3, and I can take the root of those 2 3's. But what I'm saying is, we know we're ending up there. We could do it right now, just like in fractions. And I'll take this 3 here and this 3 here and bring it out. And whatever's left in gets multiplied. In this case, there's only a 2 left in, nothing else to multiply at times, and I just have 3 times the square root of 2. I'm just going to do it before I do the actual multiplication. I'm looking for stuff that simplifies. So that's the idea. Do it right on the step where you have the multiplication taking place, because you already have things separated. All right, so try to take that concept and use it on B. Please note you've got a cube root. Take a look at what you've got. See if you can do any simplifying before you end up multiplying. Remember, anything you simplify comes out as a multiplier, and whatever's left in is left in. Don't forget your index. See what you can do with that. All right, those of you that are done on 3, give me your answer. 1, 2, 3. All right, heard a lot of the correct answers. So you look at that 25 and you know it's a 5 times 5. And you look at that 10 and you know it's a 2 times 5. Okay, good. 3 5s. I'm getting a 5 out. I also notice 2 x's and 1 more x. I'm getting an x out. Whatever's left stays inside. Don't forget the index and cube root of 2, right? Now, sometimes you have stuff left in that you end up multiplying as well, but you do it after you've done all your simplifying. Simplify before you multiply. Don't multiply everything out, then have to unmultiply to simplify. It makes no sense. It takes extra time and causes another probability of mistake, and you don't want to do that. All right, so what we just did is what I want to emphasize in 3. You can simplify before putting it under one radical sign. So go ahead and try, let's do A and B and pause, and then we'll do C and D in a moment. All right, go ahead and do A and B, and then pause, and then C and D. You might want to pause the video if you're watching this at home. All right, so what do we got? A 2 and a 7, and a 3 and a 7. All right, so clearly our 7s are coming out. And what's left in? The square root of 2 times 3 is 6, right? So 7 times the square root of 6 is the first one. How many got that one right? Right, and again, pretty easy, right? These shouldn't be hard, at least not when it's just pure numbers. You know, a 12, you know what I'm going to do with that? I'm just going to take this 2 out right here. We all know the square root of 4 is 2. I mean, you can further factor it if you want to. but a 4 is a 2 times 2, and we all know the square root of 4 is 2. I'm going to take care of it right now. 30, 3 and a 10. Hey, am I going to bother to factor that 10? I'm not. Is there going to be 2 of anything? I know there's not. I'm not going to take the time to make the 10 a 2 times. So I'm thinking as I go, right? You're thinking as you go. And that's it. Times square root of 10. So we're going to clean this up. 6 times the square root of 10, right? Any questions on those two so far? Any questions in what we're doing? Anybody? All right, well, C and D obviously are a little bit more interesting. C more than D. Go ahead and see what you can do with those two. Go ahead and try C and D. All right, so you look at C, and I'm just looking at this 20 as a 4 times 5. So you know what I'm doing. All right, I already see 2 2's there and a third 2 there, and I'm getting a 2 out. And you know what? That's all you're getting out, right? Nothing else is coming out. Don't forget your index. What's left into the numbers? 5. I've got an a squared b, x squared, y squared, right? And that's how that's staying, because it's a cube root. So all we're getting out is a single 2. Everything else stays as multipliers. I'm going to get that right. Okay. And then you look at D, and D is similar. There's not a whole lot we can do here. 6 is a 2 times 3. And so I do have 2 3's, and I can take the square root of those 2 3's and get a 3 out, and that's it. The only question will come into play is, did you leave your answer in the best final answer form? Well, I got a 2 and a 5. Be careful, be neat so you don't skip anything, right? That's a 10. NPA, is that the way I'm going to leave it? How am I going to leave it? ANP, right? Because the best way to leave a final answer is the variables in alphabetical order. Right? You just go in alphabetical for your final answer. It's the best way. Any questions on those? Anybody? Any questions on any of those? Okay. So the back is just a little bit more involved. So what if we have coefficients? All right, well, it's no big deal. Anybody want to finish the rule for me? Somebody raise their hand. How would the rule go? Quinn? Correct. So AB times the nth root of xy. Right? Just like you would expect, just like we've learned in other situations with variables, you multiply the coefficients, right? So it's the same situation here. A times B times the nth root of x times y. Again, look to simplify. Right? SBUM. Simplify before you multiply. Will you always be able to simplify there? No. But at times, you can. All right, so let's get some practice. Here's the first one. Try B. Now remember, SBUM, simplify before you multiply. So you can see there's not a lot of simplifying here, but there is a little, right? That 10 is a 2 times 5, and that 6 is a 2 times 3. And we all see we can get a 2 out. So again, what I'm doing is that 2 comes out as a multiplier. I can put it in the front of the whole thing, or I can stick it here. I'm just going to stick it there, right? Would you agree it's a multiplier? Doesn't matter whether I stick it there or if I stick it there. Just if you stick it in the front, I'd use a parentheses here so it's clear that you're multiplying. Don't put it in both places, right? You didn't get 2 2's out, did you? You got 1 2 out. All right, so what do we got? 2 times negative 2 is negative 4. Negative 4 times negative 4 is a negative 16 is your coefficient, right? And what's left in? The square root of 15y. So negative 16 times the square root of 15y. How many got that correct? Okay, not enough. Do you see your mistake? Have you made one? questions? Make sense? Okay. All right, try the next one then. See what you can do with that next one. It's a quick one, right? Can you simplify any of the radicands? Yes or no? No. So all you're doing is multiplying coefficients. Hey, this is 15 times the cube root of 10x squared, right? And that's it? That's all you're doing with that one? Hey, sometimes you can simplify, sometimes you can't. Sometimes you feel like a nut, sometimes you don't. All right, you guys are probably even too young for that commercial, huh? Does anybody know what commercial that's to? None of you, huh? All right. I'm showing my age. Sometimes you feel like a nut, sometimes you don't. Peter Paul Almond Joy has nuts. Mounds don't. All right. So it was Almond Joy in Mounds commercial. All right. Go ahead and try D. See what you can do with D. All right. Think about what you got now on D. Apply the principles we've learned in other algebraic situations like this. So let me help you out. What one main word comes to your mind on D, Zach? Distribute, right? All right, so be careful. You're distributing. Okay, so let me take this one slowly. Right, obviously here, let me use my red. We've got to distribute this, right? So the first off is the 3 times the 5. I'm already looking at my radicands, by the way. Are the radicands going to be able to simplify? Square root of 2 times square root of 7. Not on this first distribution. Do you agree? Right, again, watch. Now look. It's coefficient times coefficient, radicand times radicand. Will a 2 and a 7 simplify? No. So I'm fine. This 3 times 5 is 15. And square root of 2 times square root of 7 is square root of 14. That's the first distribution. Now, the second distribution, normally I see already the simplification of square root of 2 times square root of 2. You may not. So let me do it as if I didn't notice that. All right. Coefficient times coefficient. 3 times 1 is a negative 3. And then radical times radical. So you end up with the square root of 2 times 2, or the square root of 4, right? And that is simplifiable. Again, I'll normally catch that right now and have just a negative 6 there. But you just got to catch it. Make sure you catch it. So where do we end up with? 15 times the square root of 14. And then again, when you take this and take the root, you end up with a 2. So we end up with minus 6. 15 times the square root of 14 minus 6. How many got that correct? Ooh. All right. Where were your issues? Talk to me. What's going on that messed you up, John? Okay. All right. We didn't do adding radicals yet, did we? It's coming up. Adding radicals, listen now, is like adding like terms. What's 3 Oreo cookies and 4 marbles? 3 Oreo cookies and 4 marbles. So you can't add radicals unless they're exactly the same. They're different things. So you can multiply them, no problem, but you can't add up the radicands. It's not true. Here, I'll show you a real quick example. Don't write this in your notes. Square root of 9 plus the square root of 4. We all know the square root of 9 is 3 and the square root of 4 is 2, so the answer to the problem is 5. Does that equal the square root of 13? No, right? It doesn't work. You can't add radicals that don't have the same radicand. All right, what else did you do that messed you up, Zach? 15 times 2 times negative 3. Okay, so you multiply too many things. Yeah, too many things. Because again, that second distribution is that coefficient times coefficient, radical times radical. All right, so let's see if you can clean up your mistakes and try E. Let's see if you can get E. Learn from what just happened. Let's see if we can get E. All right, let's see how you did. So again, this is what I'm thinking on this. The 2 times a 1 is a 2. But I'm also looking here, when I do my square root of 3 times square root of 6, I'm thinking of my 6 as being a 2 times 3. And remember, it's best if you'll simplify before you multiply. If you don't, at least leave it as 3 times 6, so you'll simplify there. But I see the 2 3's, and I see I'm getting a 3 out. What's left in the front is a square root of 2. Does that make sense? So your front should be a 6 times the square root of 2. Now in the back, all you have in the back is coefficient times coefficient, but you still have it times this square root of 3. It should have ended up with 6 times the square root of 2 plus 14 times the square root of 3. How many got that correct? Okay, more, but we still got to get everybody on board. So again, questions? What got you? What's getting you? Why are you missing that? What part are you having issues with? Questions, anybody? Anybody? All right, try F. Be careful, couple pitfalls with F. All right, so you're looking at this one again, we're distributing. Negative 1 times 2 is a negative 2, hopefully you agree. And for the radical, are you going to be able to simplify? No, you have a 6 and a 5. You won't have 2 of any factors. That's going to go a 30, right? On the back, negative times a negative 8, positive 8. Do you agree? Let me leave the radical right now as a 6 times 10. For some of you, it's safer if you write it that way right now and then do your simplifying on the radicand instead of trying to do it before you actually multiply. So for a lot of you, you're safer writing. Don't write 60 though, because then you just got to go right back from that. Leave it 6 times 10 and then do your simplifying there. And hopefully you see the 2 that comes out as a multiplier of that radical. And so where do we end up on this? Negative 2 times the square root of 30 plus 16 times the square root of 15. How many got that correct? Okay, good. And I see some of you that missed some of the others getting that one correct, so that's good. And you just got to be careful, right? Here's the thing. Any math problem, especially these, how many operations are we doing? We're doing 4, 5, 6 things. You got to go 6 for 6 or 5 for 5. If you're going 4 for 5, okay, you're close. You just got to be more careful. Don't make those mistakes. Hopefully you understand what's going on. I need to give you one more. Let's do one more here. G. All right, be careful. You're going to have to apply past knowledge to this. Here we go. Parentheses. 2 times the square root of 2 minus the square root of 6 quantity squared. See what you can do with that. 2 times the square root of 2 minus 6 minus square root of 6 quantity squared. See what you can do with that last one. Nobody tried to apply the rule x to the a to the b equals x to the a times b because you have a binomial, right? And hopefully everybody started this way. Yes? Right? 2 binomials. And we all know how to multiply 2 binomials. We're going to distribute. All right, so watch. 2 times 2 in the front is 4, but what's the square root of 2 times 2? What's the square root of 2? All right, I'll do it this way for you so it'll be clearer. That's the first term, right? Distributing to the back. 2 times negative 1 is a negative 2, and you have a 2 times a 6. I'll do the backs in blue. Negative square root of 6, so negative 1 times 2 is a negative 2, and then you have a 6 times 2 radicand. Negative times a negative is a positive, and you have a 6 times 6 radicand. Okay, that's just straight so that I don't have to worry about simplifying in the midst. Agreed? We know how to do that. We're just distributing, right? Okay, so let's start looking at the simplifications. This one I get a 2 out, and that leaves me an 8, right? This one I also get a 2 out. So that's going to be a negative 2 times a 2 for a negative 4 times the square root of 3. This next one I also get a 2 out. And I get another negative 4 times the square root of 3. On the back, I get a 6 out, right? Plus 6. So let's see if you finished up well. Did you add like terms to finish? Just mentioned that a minute ago, right? 6 and 8 is 14. A negative 4 of them and another negative 4 of them is a negative 8 of them. Did anybody get it? Anybody? Should make sense as we go along, right? It's stuff we already know with the idea of distributing. The only difference was adding the like terms in the middle. All right, you got your assignment there. Hey, I'm sorry for giving you work over the break. I know that's a pain, but we are so far behind due to all the snow and ODAX and all that stuff that there's just no way around it. And then we lose a week due to achievement testing. So I'm sorry, but I couldn't figure out any other way around it. Hey, take your math book with you to class today. Right? I mean, look, you might have a class where the teacher's not going to give you anything. So sit there and start doing your math homework. Maybe you'll get it done in school today. I dare say that if you really tried to, you might be able to get it done in school today in the course of the day. And that would be great. Then it's done. Just be careful, though. Again, we're just so far behind. I'm stuck there.